Not yet, yeah. I'm just waiting.
No?
Yeah,
No?
no, it
Yes.
started.
Yeah. So I would like welcome everybody uh, for this last meeting of this year for SPWLA Iraq. Myself, Mazil Hilali, working as a senior petrophysicist for local international in their West Gunna 2 project. Um, I will leave the floor for Dr. Mohammed Jawad Zain Abidin. He's our VP of Technology. Um, and I like to thank our tutor, Mr. Brijesh from Aspen Technology, and our attendees. Thank you and Happy New Year in advance.
Thank you, Mr. Mazen. Hello, everyone. Today is the 15th of December 2024. We at SPWLA Iraq chapter are excited to welcome you and to have you join us today. My name is Muhammad Jawad Zainul Abedin, VP of Technology at SPWLA Iraq chapter and Senior Faculty Member at Department of Petroleum Engineering, College of Engineering, University of Kirkuk. The 10th webinar in 2024 production logging analysis utilizing GEOLOG software of Aspen technology will be presented by our speaker, Mr. Brijesh Kumar. Welcome again, Mr. Brijesh Kumar. Our events in SPWLA Iraq chapter in 2024, as you see, this is the final of 10th webinars in this year were conducted, and today we will see the final one, and we would like to thank in advance all companies which sponsored SPWLA Iraq chapter in 2024. Super Learner Special Certificate will be presented or granted to attendees of 6 webinars to be awarded in December 2024. Please change your location to Iraq chapter if you are working in Iraq oil industry. I mean the members at SPWLA in general. So, dear attendees, please note also that during the presentation we will share a link in the chat box to join the SPWLA Iraq chapter on LinkedIn. Thank you, and the floor is yours, Mr. Brijesh Kumar, and you can introduce yourself in detail.
Thank you, Dr. Muhammad and Mazin, to provide me opportunity to present geolog technology. So my background is petrophysicist, and I have 18 years of experience. And for past 12 years, I am based in Kuwait, working closely with all the Middle East clients. So today I'll mainly focus on the production logging workflow, which we have been developing and incorporating in GeoLog for past 1 decade. So I'll share my presentation now, and I'll switch off my video so that we have a good connectivity during the time. I cannot see the chat, so if you have any question, you can put it in chat and somebody can help in between, or we can take up the question at the end if you like. So I'm just sharing my screen. Just let me know if you can see my screen.
Yes, Mr. Brijesh.
Okay, so I'll start with a small presentation just to show the workflow. It has been a great year for SPWLA chapter Iraq. I see that a lot of a knowledge sharing session has already been done, and people are, I think, well familiar with the detailed tool about the production logging. So my focus will be just to show the workflow, how we use the data and do it in GEOLOG. So first I'll start with the presentation, and then I'll take up to to the GEOLOG to show the live demo. Okay. So GEOLOG is a formation evaluation software. It's a complete package, not restricted only to one open hole or cased hole. So we have everything starting from petrophysics, deterministic or optimizing petrophysics, adding on with advanced petrophysics like NMR processing and interpretation. You can see we have advanced geological workflow like geosteering, some machine learning with electrophysics, borehole image processing, and then obviously the cased hole workflows like well integrity, casing inspection, cement evaluation, and then production log. So today our focus will be the production logging workflow within GEOLOG. So how does the GEOLOG model in production logging model in GEOLOG help us? So it's help us evaluate performance well on a well by zone basis, and we can interpret a spinner, both the basic and array tool, and then the temperature tool. We can calculate fluid volume flowing from the completion zone, and then obviously because we have all other tools within formation evaluation, so it's easy to integrate data from open hole and cased hole together. So what we will see is what is the main feature here is that we have a single display, what we call production logging viewer, which is very easy to integrate the data, load the data, easy to visualize the data, multi-pass data within that, uh, spinner calibration plot with that, and then automatically calculating the flow from that. So it create automatic table from the calibration plot, your gradient and intercept, and then calculate the flow and hold up. So calibration picking is very interactive. You can do interactive on the plot. Um, there are interactive cross plots for the array spinner tools, and we have been adding a lot of features in the past years. And with the recent release, also we have upgraded the array spinner tools. And as I said, it automatically calculates the flow rate and volume at the downhole condition. And if you can provide the surface flow rate value like BG and BO, then it can calculate the surface flow rate. So this is a typical production log viewer, which allow us to put some general parameter, add the data, and automatically generate the calibration plot, allows us to put a lot of important input like internal diameter. So you can see you can choose spinner data, array logs, or temperature, and accordingly you can choose your input data. So what it does is it automatically picks all the important logs from different passes. As we know that in production log we have up and down passes. So it pick up cable velocity, spinner data, density, pressure, and temperature. And then we have option to add some additional logs here. Okay. GEOLOG provide a tool called well schematic where you can design your well, put all the inputs from for the casing, tubing, and perforation. So you can directly use those data. Otherwise, you can input separately your production log interval to incorporate for flow calculation. So casing diameter, if you have casing so you can directly input. Otherwise, if you have caliper first axis log, you can input that also. Obviously, flow rate computation, so it required some parameter. Obviously, when we are calibrating in the calibration plot, so it calculates the threshold and the gradient. Otherwise, we have option to put the default value and how your threshold value is calculated. So there are multiple options like average or calculated from all the zones. So all those or default value, like if you want to put yourself, so all those information are there. And in case you are choosing temperature log along with that, so you have option to use temperature and density log for that. And then there are two methods like for to calculate the relaxation distance. So two different methods are available for that particular purpose. Obviously we need a lot of other information, so these are default value, but if we have this information, you can input your data. So automatically, when you add the data, a layout is automatically created, and then there is an option to directly insert, the calibration zone above the perforation zones where we have the flow happening. We have also options to use the calibration zone from certain passes, so you can create a plot from the certain passes and then incorporate in that. And obviously, when we have the calibration plot, multiple options are there to have the right calibration. So there is an option to disable point. There is option to reverse the points, or you can click on edit intercept log and try to put your own input, modify the data, and have the right calibration. So you know that the calibration is basically your spin versus the velocity, and from here we calculate the intercept and gradient, which is used for the velocity and then flow calculation. So once we have the calibration plot, once we have calibrated it, as I said, it calculate the gradient and intercept, which is then used for velocity calculation. So we have threshold velocity. We have option to um, mm, choose the spin basically so slip the velocity method from here. Okay, so based on your flow profiles, and then finally your fluid velocity. So based on this input, like the gradient and intercept, which is calculated, and then the velocity threshold. Okay, which is calculated, as I said, from different method. Like it can be average value from all the zone, or it can be calculated by negative and positive passes. Yeah, so it can be calculated here, or you can give your own input here. So when we have the gas and the liquid together, then there is an option to adjust your flow map for the slip velocity. So you can directly click here. You can see your flow regime. You can change your values according to your reservoir, and then automatically update the slip velocity, which is basically input for your uh, flow calculation. So there are different methods within that. Okay, so you can have edited method, and you can calculate also by giving your input. So so this is graphical, so you can move the point with your mouse, okay, accordingly. So to have the right flow regime. So within the same one, we have option finally to input the different kind of flow, whether it's single or multi-phase flow. So you can have either one or two or three, and accordingly the other parameter changes. If you have like one phase, obviously it need velocity. If we have two phase, then we need density as an input, and then if we have three phase, we need the third parameter, which is like hold up or capacitance law. Okay. And when we are inserting a calibration zone, then we can calculate the flow rate for the calibration zone, which we have picked, graphically, or you can have, the computation flow rate for the perforation or inflow zone. So both way you can choose and you can calculate. Then there are some important parameters which is required, obviously, the downhole properties of the fluid, which you can input here. Uh, Otherwise, you can choose and input, the PVT values, which can calculate all these parameters. So if you have additional values for the surface flow rate, like, the solution gas ratio, the formation volume factor, you can input, and then along with the downhole flow rate, you can calculate the surface flow rate. So as I said, you can compute hold up through zone calibration, or the perforation through the inflow zone against the perforation. So these input, as I said, are required when we have the two phase. Density is required. If we are choosing three phase, then obviously you need to have capacitor or hold up log. So we have a detailed PVT input data. So if you click on the PVT value, so you have option to calculate the gas property, the oil property, and water property. So you can choose various method to calculate these parameters, like from a specific gravity or composition of 13 component or 21 component. So all these information and input are given here. So you have multiple methods also given within that, which you can use and calculate these parameters. So you can see that if you are choosing 13 component, you need to have this information from your PVT data to incorporate into this one. If you are choosing 21 components, so you have to provide those information. For wall properties, there are multiple methods provided within, and obviously if you know the specific gravity and API and bubble point pressure, then there are multiple methods to calculate the gas oil ratio, formation factor, density and viscosity. And same for for the water properties. So we have uh, tools and methods provided within this one so that you can calculate the water properties. So a very rich input to calculate all the important parameters from the PVT data. Okay, so you can see that there are multiple methods to calculate the viscosity. Okay, so once you compute everything, then you have the final output which is required, which is the input for your surface flow rate, obviously gas solution ratio, and then BG and BO value and uh, BW value. Okay, so at the end, what we want to achieve is we want to achieve the flow rate. Okay, the hold ups and flow rate. So at the end, what you get is basically your downhole flow rate. And if you have provided, the surface parameter, then it will also compute the surface flow rate here. So there is an option to, extract this data in tabular format. So it will output in that table or the data, and then you can generate, you can analyze your data, and then you can generate, a report out of that. Recently, we have added, more features to handle the spinner data. So you have option to create your own spec file for different vendors. Array spinner and hold up image can be now displayed in the layout, within the modules and within the layout, and it's an interactive plot, so you can change the segregation, how many sectors you want to create. Okay, and then it is used to interpolate your velocity and fluid hold up to create an image which is automatically generated. Okay, so a spec file, there are some spec file already provided within the software, but then in case you want to create your own spec file, you can create for different vendors. And at the end, it will generate a report. uh, you can create a very specific report from the geolog report viewer, which create a live report, which can be like if you are doing it for multiple well, this creates a template for you to generate a master report, which can be used for all the wells. So whenever you have a new well, you complete your analysis, everything will be automated. So we have a separate report view which is not only used for production logging, but any analysis we do within the geolog, and you can create a master template or report template, and it will read everything from your report or whatever sources within the software you have. Like you have generated plots, you have generated tables, you have generated cross plots, so everything can be incorporated, and it become a master report which can be used for any well, any new well, where you go and do the processing. So you don't need to create it all the time, it automatically take the output from each well. Okay, so I'll quickly go to the geolog and show you live. I have the basic spinner data, so I'll show you step by step how we do the interpretation in geolog. So before I move, is there any questions? Okay, so if there is no question, we'll take up the question at the end. This is a yeah,
Mr.
sure.
Mr. Brijesh Kumar, at the end of the session, we will give the attendees the chance to ask you,
Sure.
so you can continue, please.
Sure, sure. No problem. So this is a typical geolog launcher. Okay, so how geolog work is we have different launcher within that. The first one is called the project, where we manage to load and unload all the data. So it's basically the data management, because GEOLOG has a database. And then there is a well module where we do all the analysis. So if you click on the project module, it will open a template here. And this is used basically for data loading. I have just prepared some of the data quickly to show you. It's basically a drag and drop, whether it's a list file, delist file, anything. So say we have some delist file for down and up log. So I can just quickly drag and drop here. Okay, so it will automatically take the data. You can see here, if there are different sampling rate, what we have to do is we have to just write continue, and it will load the data in the same zone. Okay, and I can just call it whatever name I want to call it. I can call it, and then it will load the data, the database. So anything like if you have LAS and list file for different up and down run, you can just drag and drop and load the data, and it will load all the data within the data set or LAS file or delist file. Similarly, if you have any kind of tabular data, like tops or directional data or perforation data, you can drag and drop. So these are not LAS and list, but these are like a table format. So you can just drag and drop and click on import. It automatically pick the names. Okay, so whether you want to geolog understand 0 1 as a perforation zone, so take at the top and bottom. Or if you want to create some name like which is identified by geolog as perforation zone, so you can just make it alpha and put it like perforation. Okay, and load it. So I can just say so, because there is no well provided here, when you click on import, it will ask for which well to load the data, and it can load it like that. So data loading is pretty simple here. It's very easy to manage data. So you can go to the well catalog and see what are the well there and what are the data loaded here. Okay, there is a search window. So before starting, you can also search different kind of data within your database, that what data is loaded. So this is just for your data visualization or searching within the geolog. So you can quickly search that what are the data or what are the log available and how many sets these logs are available. Okay. So the next step is to launch the well module, where we have all the interpretation. Okay. So when we launch this one, so we keep the data management part separate and then all the interpretation separate. Okay. So this will launch the geolog module. I believe that some of you might be using geolog, because I know that a few companies in Iraq have geolog, not maybe all the models, but there are some geolog being used in Iraq. So this is a typical workflow for geolog workspace. So you can open the well from here. Okay, then you can visualize what kind of data are loaded here. So you can see that there are perforation zones here. Okay, you can see that all the down and up passes are here. So you can click on the log and see different kind of log here. Obviously, you can go and read through the uh, comments that what is the cable velocity and what is the temperature and what is the density. Though the production production logging model will identify itself, but it's always good to see and review your data. So you can see that we have down and up passes. There are 3, so you can use that for interpretation. Okay, so first thing, as I said, first thing I try to see the text, that whether we have all the required data or not, like the deviation data, or we have deviation and azimuth calculated or not, whether we have incorporated production log perforation data or not. So all those things need to be prepared before we start the production logging workflow. Okay, so you can see on the right side, we have all the workflows. So you can see entire petrophysics, workflow, both the basic, the multi-mean and the advanced one. We have geology, we have geophysics. Okay, and then finally the engineering workflow, within which we have geomechanics, pore pressure, well integrity, and then production logging. Okay. So the first thing what we have to do is obviously some of the parameter which are very important is obviously about the casing, the casing IDs, diameter and everything. So we have a separate module where we call it well semantic. So you can use this module to prepare your data. This is not only used in the production logging, even in the cement evaluation and petrophysics also. So you can create this one. You can input all the information for the well. Okay. Even if you are not putting, there are other options to put this input into the production logging, but it's a good idea that you can provide and create all these information for all your completed wells. Okay. So now let me take you through quickly through the production log view. Okay, so this is the production logging view because we are starting a new interpretation. So you can click on the new. If we have already done some interpretation, you can open the existing one if you have saved something. So this is a typical production log view. Just remove this part so that we can see everything here. Okay. So by default, it takes, a data set where it will create everything. It's called production log, or you can give you any name of your choice. The second thing is the input log. So when you click here, you can see what I was explaining is we have a general tab, we have the fluid flow tab, and then the phase flow tab. So in the general tab, you can, if you have information about the major surface flow rate, you can input the data here, though it's not necessary to give this data, but if you have, it's quite good. So you can input all those data. If we have information about the flowing tube head pressure, so you can provide that here, choke size. So these are all for reference purpose. You can input all this data. You can obviously, when we are doing interpretation, you can write the survey date, your interpretation date for your record, and what is the service company. So these are all for the reference purpose. If you don't have, then it's not an issue. So we can further go for the next step. The next tab within this workflow is the fluid flow tab. Okay, so here we choose, what kind of data we have. In this well, we have the spinner data. In case you have array log data, so you can add the array log, or if you have the temperature data, you can add the temperature log. Okay, so how to load the spinner data? So as I said, if you go to the text here, so we have many passes. You can see up and down passes, almost 3. Okay, 30, 60 and 90. So what we can do is we can go here and we can select the log from here. Okay, so I can select all these passes, 3 up and 3 down passes. Okay, so if you select, it will automatically pick up your cable velocity, the spinner data, density and pressure. Okay, and then the temperature. So you have to make sure that it's picking the right temperature. You can choose the right one. You can just fill down and it will fill down all the right temperature log here. Okay, so there are some other input which is required, like obviously the internal diameter. Okay, or if you want to add some other, like if you want to add, if you have additional log like caliper first log, you can add that data also. So if you can click here, go to any of the maybe the first one. Okay, and try to see if you have this data. So you can see this one, first one. You can choose this data as an input, or you can directly use the casing ID. Okay, for the zone where you have perforated. Then is the perforation log. So as I said, if I click here and go to the perforation log, so it will pick the perforation. Okay, so you can see it will indicate the perforation and it will indicate all your data here. Okay, so you can see the spinner log, the pressure, temperature, density. Okay, in case you have created well schematic, then instead of using your perforation data, you can directly use the well schematic here, and then it will represent the perforation zone. So there are multiple ways to display and input your data. For other logs, you can always input other logs like gamma or CCL log for for QC purpose. So you can just click on gamma. See here. So you can CCL log. So you can input some additional logs in your data for display and QC. So when you add the data, you can see that gamma and CCL log are added here. So what you can do is you can add gamma log from all the different passes. I'm just showing you one, but you can add as many gamma log as you want from all the passes. Okay. So this is basically from the flow rate, basically spinner data. So you can see that there is an option to calculate the threshold velocity. You can calculate this from the obviously the calibration plot, or there is an option to have average value, which means that it will take the average from all the up and down passes. Or if you choose default, then it will take your default value, whatever you provide. Okay, so there are multiple options to do that. So simple calculated log is basically your negative and positive, divided by 2. So it will take, that way. Average value, it will calculate, calculated value from all the passes, and then average out and then default. Okay. Now we have option to put, velocity profile correction factor. This is provided, um, in case, if you want to correct for the slower moving, fluid against the pipe wall. So in that case, you can use this parameter. Okay. So nothing left here. Yeah. So in case you have array data, array spinner log, then it will automatically pick up the data when you load the up and down passes, and it will allow you to process in almost the similar way, how we process the spinner data. But obviously the array data has some different way of display, and you will see multiple calibration log here when you add the array data. Within the same tab, we have option to show the apparent fluid velocity track, mass track. So if you click on, it will create an apparent fluid tab. Okay, for additional QC. So you have to provide, the logs, and then it will create that log. Create a additional log. Well, okay, there's additional thing which is here. You can see. You can add some station data that is mainly for the reference purpose. So, but it will show where are the station data within that. You can just use it as a reference at calibration purpose. So you can add those data if you have in your well. Obviously, in case you want to add some new data, you can always, click on the plus button here, and it will allow you to add a new data or new pass if you want. And then at the end, we have something called, create a pseudo density log. In case your density log is missing, it will allow you to calculate, pseudo density log from the pressure log, but it require, your survey, and then you can also smooth it by, some smoothing factor. So once you click OK, you can see that it will calculate a pseudo density log here. Okay, so this is your original density, and this is your pseudo density. So the general tab and the fluid flow tab. Finally, we go for the interpretation, which is phase flow. So in case you choose just one, a phase, then it will use the spinner and velocity data. Okay, you can define your output here. So I can just type, output set. When you choose, additional log, then obviously for the fluid identification, you need additional log, and that is density. So we can choose density. Okay. And in case if you want to, if you have 3 phase, if you are using, then you need 2 logs, for two fluid identification. So you can add capacitance log here. Okay. So let me find that log. It's called. So if you want, you can add, this density and capacitor log from all the different, passes. or if you want to take a reference from one pass, that is also okay. So to calculate the fluid the flow and properties, obviously we need the downhole properties of the fluid, so we can input the values here. Okay, in case you want to use PVT to calculate all those values, you can click on PVT. So all these methods which are showing are here. You can directly use from specific gravity or 13 component of gas composition, so it will allow you to input your data. Multiple methods are available here. You can use based on your reservoir and calculate this parameter. Okay, so same for oil properties. Okay, so you have option like edited, so you can put your own parameter if or you can use different methods here. Okay, so what it does give is to give you the fluid properties and also solution gas ratio and the formation volume factor. So you can calculate everything from your PVT data. So it's quite rich, and a lot of options are available here. You can see that you can have calculated edited value. Obviously, if you have this data, you can input directly, or you can use any of these methods. So once you complete, you'll get the two inputs which is required for surface flow here. Okay. So we can input value here. I'm just putting the default value. Okay. In case we want to compute the surface flow rate, we can provide this data. Okay. So when we have completed this one, then we can go for interpretation. So the main step is to identify the calibration zone. Okay, to have the calibration plot which is between the cable velocity and spinner. So the purpose, as I said, is to calculate your intercept and gradient and threshold velocity. So it will be computed here. So there are two ways we can do it. As I said, you can compute this for the calibration zone or for the against the perforation zone or inflow zone. Okay. So adding calibration zone is pretty simple here. You can see that this is our perforation. So we can add a calibration zone here. In this example, I have just one perforation. So I can just click here, add a perforation zone here. At the bottom, I can add another one. So you can see that I have just added two calibration zone here, and it will indicate the zones here. Okay. So once you apply, it will automatically calculate your gradient and intercept. Okay, as I said, if you go to the edit intercept, you can do the slight changes yourself if you are not happy. Okay, but as I said, the method which is used for this one is basically either the calculated value, which is this one, what you see here, or if you choose the average one, which is basically average of calculated value from both zone, or you can have your own default value which is given here. Okay, so ideally we go with the calculated one on the calibration plot. Okay, and this is very iterative. So you can see that the up passes and down passes, three up pass and down, up pass and down pass. So there are multiple options available here in case you are not happy with the calibration and you want to remove some of the points, to make the calibration, or you want to, reverse the spin. Okay, so you can do that also, or enable the point. Okay, so it will automatically calculate your the gradient and intercept. Okay, and based on that, the threshold velocity is calculated. And based on that, obviously, again, the calibration zone, it calculate, the fluid velocity, the hold up, the slip velocity. So you can see everything is calculated here. And for the slip velocity, in case you have used the calculated value here, okay, there's an option to modify your slip velocity based on what kind of flow regime you are. So it can be done, uh, graphically. Okay, so you can apply that, and you can change the parameter accordingly. Everything will be updated. Your hold up value and hold up calculation is updated here. Okay, so multiple methods are available here. You can see that if you go here, you can do it for both zone 1 and zone 2. Okay, and either you can use the calculated value or you can use the edited value. Obviously, some parameters are required here for the gas density and oil density and viscosity. Okay, or you can change it graphically here if you want. So you can see that all the flow regimes are here. Fine bubble, bubble, churn, and then annular. So according to your calculation, it will indicate it automatically, or you can slightly change it if you want. So the flow of the hold up and the flow are calculated, as I said, both for the calibration zone, okay, or it can be done for the perforation zone. Okay, so you can, if you go here, there are other options like you can compute the hold up for the calibration zone. You can do the zone calibration for the calibration zone. So when you update it, apply it, you can see that it calculate everything. So the computed, hold up, computed flow, and zone contribution. You can see against the perforation. So if in case you want to see it against the perforation, you have to just go and just click on the perforation. Okay, so this is the typical workflow within GEOLOG to compute. There are some other things, like as I said, for the array tools, or in case if you are choosing the temperature log, so there is an option to choose temperature and density, and you can incorporate that also. You can calculate the fitted temperature log also for QC purpose. Okay. So if you go here against the calibration zone, it will calculate temperature in the red color. You can see here, or in this zone. So against your calibration zone, it will calculate. So this is a good idea to QC, in case you want to, calibrate it. Okay, so let me see if there is anything else here. So once you have computed everything, you have calibrated your data, plot, you have calculated uh, your velocity, hold up, and flow, everything. So what you can do is, if you want to calculate, the surface rate also.
الشحن نعم ده حطاه الشحن ده طلعه فوق
So this is maybe I'm just putting some default values here. So in case you want to calculate, the surface flow rate, you can provide this data, okay, and then apply, and then it will calculate, both the surface and downhole flow rate. So you can see now it is calculated downhole flow rate from the zones, and then obviously the surface flow rate also. So in case if you have information, or you can use PBT to calculate this parameter to get, the surface flow rate also. And if you have information about the surface flow rate, so there is an option to provide this parameter at the beginning or also here, and you can try to match them. Okay, so it will try to calibrate the surface flow rate computed by this workflow and actual surface flow rate which you have got in the well. Okay, so I don't have right now data prepared for array tools, but just to tell you that in array tool, we have option to choose some of the spec file has already been defined, like for Schlumberger. So you can design your own spec file. You can add different layers, especially in case of stratified horizontal flow. So you can add different kind of layer as per the tool. Okay, for the spinner, for the gas hold up, and for the water hold up, you can create it. And when you add your array data, okay, array production log, then it will automatically create all these three displays and calculation accordingly in the layout. what I have shown basically in the um, in the presentation, that it will create a spinner plot, array gas hold up and array water hold up. Okay, with the image you can see here. Okay, so this is all about the GEOLOG production logging workflow. I hope I have covered everything, or if you have any questions, I'm happy to answer those questions.
Thank you, Mr. Brijesh Kumar, about your interesting lecture today. So let's go to our attendees, and if anyone has any question, so he can or she can write, or you can raise your hand, please. Yes, Mr. Abbas Radi, you can speak with Mr. Kumar, please. Ask your question.
I see hands up from Abbas. So is there any question, Abbas? Either you can put it in chat or Abbas, do you have any question?
I think Mr. Abbas cannot open his mic.
Maybe
Mr.
you can
Abbas
type the
Radi,
question.
yes. Mr. Abbas Radi, you can type your question, please, in the chat box in order to answer it by Mr. Brijesh Kumar.
Mr. Kumar, can I have a question? It's Lev Paganov.
Please go ahead.
Yeah. What are the main issues during the production logging interpretation and with this alignment of velocities and spinning speed, and how the specialists usually solve it here in the software?
So I mean,
the non-common issues. I mean, is it like a water cut or is it like a gas, and how we see it in the login templates here?
I mean, there may be so many issues with during the logging, but as I see that some of the issues we face, like if we have cementation and you have channeling within that, because what we are trying to find here is the flow, okay, which is happening from the perforation zone. So everything what we want to do is based on that flow, based on the spinner velocity. Obviously we try to solve for the flow rate, okay. The difference between the tool velocity and the fluid velocity which is flowing, so we try to calculate that. But some of the challenges are like obviously the channeling which is happening, the perforation interval itself. Sometime you can see that here you can see that the entire perforation zone is contributing, but sometime what happen is that you have perforated quite a big zone, but actual flow is coming from the certain zones. So all those things from the interpretation you can identify, and you can do a remedies method. Obviously, the temperature log is also quite useful here along with the spinner log, because the spinner log obviously see what is flowing within the well actually, but not outside the borehole. So temperature log can indicate anything which is like happening within the cement channels, if something flowing there. So those are the things we have to make sure that mm, we are focusing on. Sometime in it there are some noise while doing it, so you can obviously see the temperature log or other logs, that if there is some noise. And because that's why we have so many up and down passes, and the purpose of so many up and down passes is that we are not taking just one pass to uh, have a proper outcome. So that's why, in case we have some passes which are not good, you can exclude that. If we have some issues in the temperature log or any data, so you can just go and correct or remove those data. So you can launch plot, you can remove those data. Okay, so we have to make sure that there's no noise in the data. Obviously, we have to make sure that the interpretation itself help that our production is coming from the entire interval or certain part of the interval. Okay, that will be helpful in calculating kh. That will also be helpful in doing some remedies. If there is cement issue, then that will help in fixing the cement also. So those kind of thing we can you know try to QC those data, and obviously mitigate that. So the multiple passes why we do here is to basically and negate some of those issues in certain passes or certain data. Is that answer to your question, or you are looking for something else?
No, in general, yes. Thank you.
Thank you, Mr. Lev. I think Mr. Abbas has two questions. You can read them, please, Mr. Kumar.
Let me check the chat here. Okay, so obviously the first answer, as I said, in the flow behind the casing, temperature log is a good indicator for that, because it sees beyond the borehole towards the formation. So temperature log some can help in the packer leaks or the flow behind the casing. So that is one thing. That's why with the spinner, if you have temperature log, we can combine together and do the interpretation. Okay. Um, the second question is how many difference in downhole flow rate and surface flow rate can be accepted? I mean, generally what we do is I don't have really idea about how much acceptance level is there. It's depend upon the company. Obviously, there is a lot of uncertainty within the parameter. But if you don't have the PVT data or something like that, obviously there is a lot more uncertainty. But in case you have some PVT data, then we try to reduce this uncertainty. So calculation of your the volume formation factor is quite key and important. So if we have those data, then we can mitigate this uncertainty, and we have quite good calculation of the surface flow rate. Obviously there will be difference. So it's not about how much difference there should be, but the real question is that whether the surface flow rate is correct or not. Okay, so whatever we are getting downhole is what we have calculated from the method, and the surface will obviously be. So there is no scale to say that how much different it should be. It's basically on your formation factor basically. Okay, so the more accurate it is, the more accurate your surface flow rate calculation will be, more acceptable you can say. But if you don't have data, then it will have more uncertainty on that.
Okay, Mr. Brijesh Kumar, we look to the chat box and to our attendees. Please, anyone has any question, he or she can raise his hand, or you can type your question. If we don't have any question, so we can close our webinar for today. Okay. Thank you.
So just to, highlight something else also, like what we have, as I said, the question about the surface flow rate. So if we have PVD data, it's quite good. This method is also incorporated outside within the production logging also, so anybody can use it. So you can calculate. And this is not only, useful in case of, production logging. Why we have put it outside also, that in case of, unconventional, you need, BO and BG values, so you can calculate it. So this method is also available separately in case you want to use it, outside and then incorporate the data here, you can do that way.
Okay, Mr. Kumar, any question, please? Okay, there is no question more. So at the end of our webinar, we would like to thank Mr. Brijesh Kumar for your informative presentation about production logging analysis utilizing GEOLOG software of Aspen technology. On behalf of SPWLA Iraq chapter, I would like to extend my sincere thanks to all lecturers, participants, and sponsors who supported the SPWLA Iraq chapter webinars throughout 2024. Your invaluable engagement and contributions have made these events a success. A special thank you to the companies that sponsor the SPWLA Iraq chapter's activities throughout the year. We look forward to continuing this collaborative journey in 2025. Wishing you all the best and happy Christmas. And I look forward, and certainly SPWLA Iraq chapter with Mr. Mazen, the president of SPWLA Iraq chapter, and our officers in the SPWLA Iraq chapter. Look forward to seeing you in the upcoming sessions. Thank you and bye-bye.
Thank you, Dr. Mohammed. Yeah. Thank you.
you,
Just
Dr.
one last
Mohammed,
one.
and,
Yeah.
thank you, Mazen. I have shared my email ID in case somebody have some questions, so I can share more details, and more documents on any specific questions. And if somebody has any requirement or request for the software itself, you can write to me, and then we'll work on that.
Thank you, Mr. Brijesh. And I like to extend my thanks for all our sponsors during 2024. It was really a busy year. I hope it was beneficial for everybody. We make a playlist track regarding all this PLTs, regarding PLT, like interpretation tools. In our YouTube, we try to give an equal opportunity for all the software companies. We were so happy to host GEOLOG as well. Okay, so we'll have everybody. Next year have been discussed internally. Most probably will be all about machine learning, and I like to thank our SPWLA Iraq committee, mainly our VP of Technology, Dr. Mohammed Jawad Zail Abdin, for his sincere efforts to support all these technical events, and wish you a happy new year. See you in 2025. Thanks all, and thanks for all our attendees. Have a great year ahead.
Thank you, everyone.
Mr. Mazen. Thank you, Mr. Brijesh.
Bye-bye. Bye-bye. I'll conclude the meeting. Have a great day.